Hello, good morning, and welcome to this Logistics Manager webinar. I'm Christopher Walton, editor of Logistics Manager, and I'm your host for this interactive session where AD-Link will discuss automating fulfillment with artificial intelligence, but without disruption. Let me ask you a few questions. Are hand scanners causing accuracy issues? Are you missing in-action inventory with no explanation? A delivery is sent to the wrong location, or wrong items sent in a delivery? Are your customers increasingly asking for high mix orders that are time consuming to fulfill? Are you coping with labour shortages? Is human error on the rise? Are you suffering shipping delays as a result? If you said yes to any of those questions, then you're in the right place. Today, I'm going to discuss with AD-Link how machine vision artificial intelligence works in fulfillment centres as a way to quickly and inexpensively increase automation and reduce risk. We'll focus on receiving and storing, bin picking, packing, shipping, and safety and security. We'll also discuss the basics. What is it? How does it work? Why does it matter now? And we'll share real-life examples, lessons learned, and tips on how to get started. Today, I'm joined by Niels Courtsey, Product Director, Edge Solutions at AD-Link Technology. Niels has more than 15 years of technical expertise and experience with real-world industrial applications. As Product Director, his portfolio of machine vision and edge AI solutions are driving efficiency, productivity, and automation in the warehouse and logistics sector globally. So why not ask Niels a question? We'd love to hear from you. You can pose your questions throughout this webinar as soon as they cross your mind in the Q&A box you can see at the bottom of your screen. I'll be able to see them and I'll pose them to Niels. And make sure you tell us your name. We might not have time to answer all of your questions, but I'm sure Niels will get back to you after today. And that's not the only way that today's webinar is interactive. There's a major vote occurring in the world today. We thought you'd give the chance to exercise your democratic rights too and participate in our interactive polling. Throughout the webinar, you'll be asked questions, so make sure you click and vote so we can discuss your answers. Now, Niels gave us a little fright this morning when his camera couldn't work on his computer, but he can still hear us and we can still hear from him. So nothing will be able to hold him back. So without further ado, let's hear all about machine vision and edge AI solutions. Over to you, Niels.
Let's get started a little bit about AD-Link. AD-Link people say as well. We always say AD-Link, and that's because it's really because the name is based on analog digital link. So that's how it all started when the company was founded. It was all about how can we turn this analog world into a digital world? How can we connect all your machines and make sure that we can build technology that can help you be more productive and get return on investment. So AD-Link is really a global player with 5 distribution centers in 5 different countries and a lot more offices for both hardware and software engineering. So initially starting really as a hardware company, building sensors, industrial PCs, cameras, big servers for industry, and then moving on also to being a software vendor. And we are really focusing on what we call edge computing. That's where the company is really leading. And so the computing bit about the hardware and software is probably understood. What we mean with edge is really doing it close to the source of the data. So if there is something happening in your warehouse, it makes sense typically to process that information and to take action close to the source instead of sending information maybe into the cloud. So we build a lot of solutions for warehouse automation, and some of them you may have heard about or maybe not. Something like Smart Pallet we'll talk about a bit in this presentation later on. But also things like machine conditioning, monitoring, collision avoidance, smart packing. We're also part of the robotic operating system technical steering committee. Also, we'll talk a little bit about robots, and IWA a partner member, which is also relevant, obviously, for the logistics space. So we've been talking about automation in the warehouse a lot. So we've been talking about this maybe since 2011, and I've visited a lot of different distribution warehouses, and what I found is that none of them is really automated, and that's really why we're here. So if you look at where are we today, and why are we not as far as we thought we would be? At least that's how I feel. We could have been a bit further on in the journey, but it just takes more time. And why is that? We typically buy from the same vendors, and are waiting for them to make more intelligent stuff. We're hearing a lot of noise from tech companies that promise that they will solve everything for us. But yeah, what we found is that the silver bullet doesn't really exist. And if there's any company that promises that it can solve everything, I don't think it's possible. So that really takes me to the first poll question. So maybe Christopher, you can take over from here.
Apologies, everybody, muted myself. So the first poll question is, what percentage of warehouse and distribution center managers say they still use mostly manual processing? So is it 10%, 25%, 50%, 75%, or 100%? I'll repeat that question again. What percent of warehouse and distribution center managers say they still use mostly manual processes? The poll is open now. Submit your answer. Excellent, Neil. That's
Right.
a pretty unequivocal result on the back of that. That's 70% saying 75%.
Well, that's pretty good. Pretty accurate. The answer, at least according to this study, is 50% is the right answer. It could be that more people on the call are doing more manual than maybe on average. But this is something that I've experienced a lot as well. There is a lot of manual activities going on in the warehouse, and I think it's great. It gives a lot of room for improvement and making things better. So if we move on to what the world will move towards eventually, then truly I believe we are all know that the robots are coming, as the slide says here. So we're really talking about like robotic arms, maybe to do palletization, cobots as they call them, maybe things that where the robot is actually helping human beings to do their job. Drones, automated guided vehicles, fully autonomous palletization. But so we believe really this is coming, and we are heavily invested in robots as well. But what we do see is that this is typically not a good place to start. Robots are good at very repetitive tasks. So if you're really doing the same task over and over and over again, then it may make sense to invest in a robot. But if you need to do things in a slightly different way every time you do it, or maybe the material is different, or maybe the boxes have different sizes, or your process is changing, then we typically see that this is not the right way to start your automation journey. We really feel like technology needs to work with your people. It's there to help them, not to replace them. And people don't want to embrace the technology. And then also, if something new comes along, rip and replace it completely when something new comes along. So you really would like to have something that can grow with you on a journey. So you start with something, And when you take it to the next level, you can reuse what you already have. So that really takes me to what we see as the automation journey. And so I'll take you through this. So the first step is really everything's manual. So in this call, people said like 75% we're still at this level. So everything is done by human manual jobs. So no changes to standard operating procedures, well, limited investment. Then the next level will be to semi-automate this. So can we still have a manual process, but can we have some assistance by technology? So no changes in the SOP, but maybe increase accuracy and increase throughput. The next level will be, can we automate this where certain jobs are completely automated by technology? So you increase your throughput, you reduce cost, and human beings are only there to basically check if everything is still working as it's planned. The next level will be semi-autonomous intelligent systems that can actually find out that it's not working. So you only need to have a human there to monitor maybe a dashboard that says, oh, something is broken, let's go and fix it. And then the next step will be autonomous. So it's a system that thinks completely by itself. So the difference between semi-autonomous and autonomous would be where semi-autonomous would maybe be able to figure out something is wrong. The autonomous mode would also be able to figure out exactly what is wrong and how to fix it. Can it fix the process itself? And then finally, well, this is really something that I haven't seen before yet, but everybody talks about it. So let's mention here as well, is all these processes that you have working together. So maybe it's just a forklift calling upon another forklift to say, well, I can't carry this by myself. Can you come over here and help me? So that would be the difference there. So let's use an example of a forklift to make it a bit more clear. So a manual process would be today a forklift. The next step would be maybe some audio visual cues installed on the forklift to help the driver of the forklift to drive to the right location, to pick up the right pallets, etc. Automated, can we automatically slow down, stop, swerve? Semi-autonomous, we would make it driverless. So maybe consider something like the Tesla car, something that can drive around by itself. You still have a steering wheel and a driver's seat there, and you still need to make sure you're in the car and touch the steering wheel every once in a while. Autonomous would be an automated guided vehicle. Actually, there is no more room for a human being on the forklift. It just does everything by itself. And then finally, there is the level where all these AGVs start communicating with each other and solve the problem together. So let's see where we focus right now, where we see that there's a lot of gain that we can get without a lot of interruption of your process, and based also on where you say you are. We are really focusing today on the semi-automated and automated. So can we help human beings do their job? Can we make sure we can increase throughputs? Can we reduce the cost? Can we make the process more efficient and more accurate? So so that's all great, but yeah, when you're saying you don't want to be so invasive, what does it actually mean? So when I talk about this, I typically mean things like it's easy to install. You don't need like a big generator installed or completely tear down your warehouse to install the solution. Minimal changes to your standard operating procedures. Limited enablement of the workers in the warehouse. You really want to quickly forget it's even there. Right? Take it for granted. And yeah, so you see all these things here, like artificial intelligence. When we talk about artificial intelligence, it's kind of a solution that will that requires a bit of training based on examples you give it, and based on that training, it can learn to to make decisions for you. We'll talk about cloud. We see a lot of cloud solutions. People say, well, give me your data into the cloud and we'll make it work. Not invasive, but it's also something where we see it's hard to find the ROI in doing things in the cloud for at least these kinds of automation technologies. Everybody's on about IoT. Can we connect the machines? Can we connect the unconnected, as we call it? Put some sensors on and use the measurements from these sensors and take action based on what you're actually measuring. And then machine vision, that's the one that we see a lot of value in. So I'll focus a bit more on machine vision, because that's really where we see a lot of interest and a lot of benefit. So when we talk about machine vision, what does it really mean? So it's really, I would classify it as giving machines the ability to see, just like human beings. And it's really there to do image-based analytics. Can you do quality inspection? Can you do process control, worker safety? But also, if you move to the next level and you want to install robots, can you reuse those cameras to guide the robots? So when we're talking about machine vision, people ask me, what can I do with it? Well, typically what I use to explain it is, if you install a video or install a camera and you take a little video of a process that you have going on in your warehouse, and you watch a recording later on, and you can conclude something based on watching that recording, and you would be able to say what's wrong or what's right, then you can also train the software solution with the AI to see that as well. So the way it works with machine vision is you need to gather some images, some example data. You need to mark them to say, well, this is what I'm actually looking for. And once that's done, there's an automated process to go and train the intelligence, the artificial intelligence that's typically in machine vision applied, and then test it. So once you've done that, you can deploy that solution right at the edge. So on the camera itself, maybe, or on a machine that's in your warehouse. You have the real-time camera feed. You capture the data, feed it into the process, and based on the outcome, you can act on it, and you can make decisions. You can make the system do things. So that's really what machine vision does on a high level. And I hear you think, well, that's maybe a bit theoretical. Can you show me some examples of how this works? So here's an example of a machine vision solution. And for this customer, we were challenged to replace their hand scanner solution. So they were suffering from inefficiencies with hand scanners. So they were palletizing manually. They were taking the hand scanner, scanning the barcode of the package before putting it on the pallet. And what they saw is that it was slow. It was also something where people just forget to scan barcodes. So packages get shipped somewhere and they get lost. So you have your shrinkage problem. But also packages can be stolen, etc., etc. So you have like not a very clear view on the inventory. People had problems with the ergonomics of the hand scanner as well. So what we've done here is actually overhead these pallets. Overhead each pallet, there's a camera installed, and this camera is just watching what's going on the pallet. So it scans for barcodes. So by means of its location, it knows what pallet it's actually focusing on, and it's able to integrate into the warehouse management system, pull the manifest, and match it against the barcodes that it's seeing, and indicate whether the package is on the right or on the wrong location. So you can't really see it very well in this video because it's quite fast, but actually when the package is put on the right location, it's flashing a green light, and if not, it's flashing a red light. Next to that, so that was really a machine vision solution that didn't really require training, because that's really machine vision where you can use rules to detect the barcodes. But next to that, we've also, and that is something you see on the right-hand side, you can see the packages being detected. So if there's a package without a barcode, then it's marked red, and if it does have a barcode, it's marked green, and that allows you to see whether maybe the package is upside down or it doesn't have a barcode, and see, well, there's a package on there that shouldn't be on there, or make sure it's not missing. So for this customer, it highly improved their accuracy, shipping, but also efficiency. It saved them 5 minutes per pallet to do the palletization of a pallet. And also what it also enabled is they were able to start delivering custom orders. So they could effectively, they were using the same boxes every time for every pallet. They were now able to switch to something where they could customize orders, and that gave them a new revenue stream that gave them about $340,000 annually. So the whole investment for them took about 7 months to earn it back, and in 3 years' time, they would expect about $12 back for every dollar they invested in this solution. So it was quite an easy choice for them to make this decision. So another example. So this is done. This is in the US. I can name this customer because well, it's out there in the open anyway. This is Evans Distribution. So they were shipping Girl Scout cookies to directly to consumers. So they're all unique orders, about 20,000 a day. But what they were suffering from is just inaccuracy. So they would get custom orders. They were all unique. So they would have somebody on this production line pack the order. So would take the manifest, pack the cookies in the box, and then it would go on this conveyor, and then there would be 2 people checking the order. But still, they were making quite a bit of mistakes. And they were looking for something where they could become more accurate. So what you see here is you see a camera on the right-hand side that scans the box for the barcode. By doing that, it's able to look up the order in the warehouse management system, and then the camera installed overhead is using AI to scan the contents of the box. So you can see all these colored boxes around the cookies. So it's actually matching the contents of the box with the order. So if it's correct, there's a green light flashing on the left-hand side there. If it's wrong, there's a red light flashing, and they could take off the box and repack it. So their accuracy went up to about 99% with this solution. And also for them, it was really attractive because it didn't really change anything in their procedure. So they got awarded by this accuracy. They got awarded the contract for North America entirely. So they're now deploying this solution onto 3 more product lines as well. Okay, another machine vision solution. This is really for receiving on the receiving side. So this is a camera installed on a forklift. And one of the issues for this customer was they were losing their inventory somewhere in the warehouse. As you all know, it can be quite big. It can be quite difficult to find stuff. So in here, they were actually seeing the barcodes on the pallet and matching that against the forklift when it actually gets picked up by the forklift, and then it gets stored somewhere, and then when it's stored in a warehouse, they're using beaconing technology to say, okay, well, it's now stored here. So this they were suffering from about 3 errors per shift with placing these pellets in the wrong location, and there were about 30 minutes of correction time required for every error. So for an operation that they have with about 35 forklifts, they were spending about 400 to 500K per year in error correction. So by putting this camera on, they reduced this to practically zero, so saving 400 to 500K annually. And then final example I wanted to show here is worker safety. So what you see here is a demo. So this is a proof of concept that we've built, and what it's doing, it's checking whether people are wearing their protective equipment, their personal protective equipment, safety jackets, safety hats. If they are wearing the safety equipment, they are allowed into the factory. If not, they will not be allowed in. So the technology will automatically open the gate if you wear it, and it will keep the gate closed if not. So yeah, the ROI for this one is sometimes difficult to calculate. It's difficult to come up with a business case. What we do know is, based on some research by the National Safety Council, is that companies spend about $1,100 on average on worker safety per worker. We also know that medical attention, if it's required, is about $40,000 per case. And God forbid if somebody dies, then we're looking at about 1.2 million. So maybe that's not a great example. But things that I did see is, when I visited warehouses, is pictures being showed to me of forklifts that have driven off platforms, or forklifts that were completely damaged because some pellets fell on top of the forklift. So situations like these are really useful to prevent, obviously. So the good thing about all this technology really is that with machine vision, the technology really is very much the same. And by just training a different artificial intelligence model, you can solve all these different problems with the same technology stack. So that's one big advantage. The other one is also that once you have this installed and you want to go into the next step, for instance, in automating, you can reuse these cameras also, for instance, in combination with robots. But yeah, what we see is that a lot of these projects, in automation projects, are still failing, and that takes me to the next poll question.
Do you want me to jump in here, Niels, and pose
the
next poll question?
Yes, please.
Not a problem. Okay, so our next poll question is, what is the #1 reason automation projects fail? So is it installation and troubleshoot caused too much downtime? Solution required too much manual intervention? Original scope didn't solve the issue, or solve the issue, I would imagine that says. Too difficult to integrate, or are there vendor partner issues? So let me repeat that again. That's, what is the #1 reason automation projects fail? So is it installation and troubleshoot caused too much downtime? Solution required too much manual intervention? The original scope didn't solve the issue? Too difficult to integrate, or there were vendor partner issues? Vote now. Oh, there we go. A fairly even split this time, Niels. Top answer is the original scope didn't solve the issue, but with 33%, but 30% also said it was too difficult to integrate. What are your takes on that?
Well, that's again, well done, audience. It's pretty good. The research actually says it's too difficult to integrate is the answer here, but the original scope is definitely the #2 here. So it's pretty close to what people actually think. So that's good to know.
We have a very knowledgeable audience,
Yeah,
clearly, Niels.
yeah,
Perfect.
yeah, yeah. Okay, so yeah, it is difficult to integrate. That's why a lot of these things fail, and also because people are see that the scope is just not solving the issue. So the approach that we take to make sure that the integration is taken correctly is that we do the connecting the unconnected. So what you see in your warehouse, you've got your assets, you've got all your sensors and all the devices that you have in a factory, and the operational technology, and then there's the IT folks with their analytics and their AI, and obviously security comes into play there as well. And then there's also some parts that that need to go into the cloud, and how do you all connect that? So what we've done is we've invested in heavily in a data sharing platform, in a technology that we call our A-Link Data River, and this is a data sharing technology that is able to connect to all these different types of assets and sensors and different technologies in OT and in IT space, and is able to let all these technologies communicate with each other. So that's just there to make sure that we can all integrate this easily. So this is a whole platform that we offer with a wide range of different applications to do the integration with different technologies. There's the select the different technologies, like I said, and then there's the apps to connect to the devices, and there's the cameras and machine vision that we integrate as well. So another couple of things. So one of the things that we get going with is, so once we have the data sharing platform, what we do next to that is, it's great, we've got this technology, we've got our hardware, we've got our nice cameras, we've got our industrial PCs, we've got our sensors, we've got our software packages to connect to cameras, to connect to all kinds of IT and OT protocols. But what we also have is we've got some prepackaged starter kits, so you can get started quickly. And one of the solutions that I mentioned in the introduction is the smart pallet solution. So this is a camera with onboard storage and compute. So this is really the camera that powered the palletization use case. So everything really is running on that camera itself. So it can scan the barcodes, it can cross-reference against the inventory, it can stream the data to the warehouse management system, and it can also connect to a screen so it can communicate with the employees there as well. The approach that we typically take is, because all these warehouses are different, and this is a great starter kit. We use a concept that we call digital experiment, proof of concept. But we start with, okay, let's start with a business problem here, and not with the technology, really. So I have talked about technology, but when we talk about the things that we're doing for our customers, we always start with a business problem. And that's exactly one of the pain points that you've all voted on is, if we lead with technology, then typically you end up with something that doesn't really solve the problem or doesn't give you the ROI. So what we say is, let's start with the business problem here and the evaluation criteria. Then we have the technology to connect the unconnected and configure our data river and get all the data that you need and stream it to where you need it to be. But we need to make sure we have the business case, and so we can do a business value assessment before we decide to move on. So really pick a problem that is small to start with, and then prove that that one is working before you move on to the next. So instead of trying to solve and boil the ocean in one go, let's start with some real specific problems that you have that you can easily get started with. And then, for instance, the palletization, that could be a good one, or maybe the quality inspection, or the order validation. Those could be very specific problems that you use. So So tips for getting started, like I said, take the digital experiment approach. Make lots of small bets, not a big one. Focus on the business problem, not the technology, as I mentioned. And also start with automating things that make human tasks easier and more efficient. So not replacing them, but just make their jobs easier. It will also help with the adoption of the technology. And this is also it's a team sport, right? So if you're saying we've got a lot of our partners and we don't need them, well, of course you do. We make sure we involve your whole ecosystem of partners. We make sure we use them and work with them. And then move the intelligence into or near the things. So that's what we call edge, the edge computing aspect of it. So if you're doing things like the palletization or the auto validation, you can't really afford to send the data somewhere in the cloud, wait for a decision to come back, and then act upon it, because it takes seconds. It's just too slow. Get started with the smart pellet solution is really a good way to get started with this. So work with us in a digital experiment with smart pellets. We've got other solutions as well. So we can use any of these starter kits to begin with in combination with digital experiments, and make your machine vision AI solution a success and give you a lot of ROI. Starting with semi-automating your manual work and then moving to automation and taking it one step at a time. So what we see really is that vision is it says it over here. It's the hottest thing since the smartphone. It's really everywhere that I come and we take this approach, we see that there's a lot of value for customers, and it's usually quite easy to come up with a business case that shows ROI. And like I said, it can be quite a wide range, all the way from palletization to order validation, to bin picking, to worker safety. So that's really my story for today. So I'll be happy to take any questions.
Well, Niels, thank you so much for your presentation there. That was absolutely fascinating. So yes, if you want to pose Niels a question, make sure you click on the Q&A box at the bottom of the screen and post your question. I'll be able to pose it to Niels. Niels, you'll be glad to know that throughout this webinar as well, we've been continuing to be joined by new viewers, and they may have missed some things at the start. So it would be remiss of me to remind everybody watching that you can actually watch this webinar on demand on logisticsmanager.com from this afternoon. So if you've missed any of it, then look out for an email in your inbox that will notify you so you can watch the whole thing. Just allow me, Niels, to kickstart the Q&A portion by asking you a question. How easy is it to integrate Smart Pallet with existing systems and processes?
Yeah, that's a great question. So Smart Pallet out of the box, it has the barcode scanning, it has the box recognition, but obviously you do need to integrate with the warehouse management system. So there's a small amount of work to integrate with the warehouse management system. Typically, every warehouse management system is different and slightly set up in a different way. So you probably need like a couple of days to do that integration. But all of the rest is just working as is. So it doesn't disrupt also the standard operating procedures. So instead of working with hand scanners, you can just get these cameras installed and tell your people, well, instead of using the hand scanners, you can just put the box on the pallet and off you go. So I would say it's really easy to get going with Smart Pallet. We can have we've seen examples of getting Smart Pallet set up on my first production line in just 2 weeks. But if we go into like digital experiments that maybe have a slightly different scope, then we typically see something around like 3 months to get a solution that is completely customized and working.
Absolutely. I have a great question here from Mei Wang, who asks, do different user types require a different edge camera?
Yeah, again, a great question. So yes, the answer is yes. So if you've seen the examples, I'll again go back to the palletization example. So there we used our A-Link Neon camera that I just showed. But if you look at the example that I showed afterwards with the smart packing at Evans, we were actually selecting two different cameras and chose to do to run the software on a industrial PC instead. And so just one industrial PC with two cameras connected. And the reason for that is just more cost effective. And you'll be glad to hear that all the software bits and the hardware bits, they're all plug and play. So if you just want to take the software, deploy it somewhere else, just do that without changing anything else. So take the software from the camera, put it on the industrial PC, connect it to cameras, and configure it to use those two instead, and off you go.
Yeah. I think that kind of leads in nicely, Niels, to the next question, which is, what is the typical cost and ROI?
Yeah, again, really a great question. So if you look at like the Smart Pallet Starter Kit, that starts at around $6,500. But if you look at a typical digital experiment, typically it starts around $15,000, but it can go up to, well, maybe $70,000 or $80,000 depending on how custom the use case is. So if you really are having like the smart pallet solution, then really it's easy. But if you go and do something completely different, then there's more customization to be done. The level of the ROI, yeah, it really depends on the use case. So like the examples that I showed, it was like the break-even point was around a couple of months. And the ROI in let's say a period of 3 years is over 1,000% for a lot of these.
Yeah. Rob Lawton asks, can the camera be fitted to a human, e.g. a picker, or in some cases a pallet truck and replace a handheld scanner?
Yeah, to human, to be honest, we haven't really attached it to the human yet, but I don't see why that wouldn't be feasible. We do have examples where we have attached it to a forklift. So that example that I showed with the forklifts, it was actually installed on the forklift. So if the forklift would pick something up, the camera could detect that it's what it had picked up, and it would also be able to see, oh, okay, it has been dropped now, so now it's been stored somewhere else. And I know what location I'm currently at, so I know where this pallet is now in the warehouse. On human beings, it could be exactly the same, but yeah, so I would say it depends, and we can set up a digital experiment and come up with okay, what's the business case here that we can solve. But I'm sure we can work something out. So I'll be happy to have a conversation about the use case you have in mind specifically.
Absolutely.
Offline.
Rob will get back in touch with you. I have a question here from Igor Greenblatt, and it's around a technology that I'm not especially familiar with, Neil, so I'm hoping you are. And he says, can you talk about a combination of AD-Link products with ultrasonic technology, and do you have any successful case studies? I'm not really familiar with ultrasonic technology, so I'm hoping that you are, Neil.
So honestly, I'm not familiar with that either.
Okay.
But what I can say is that that our solutions are both well, they are vendor agnostic. So
okay.
We don't mind using other hardware or other software components and integration. And to be honest, it's not feasible to rule the world anyway. Yeah. There's hardly any greenfield deployments out there, so you need to be able to integrate with existing systems. So that's what we do. Yeah, if there's maybe better hardware out there that you want to use, or there's better software components that you want to integrate,
Yeah.
Absolutely. We're completely open to that, and we've proven to do that as well.
In terms of case studies, Niels, do you have any projects at the moment that you're running in Europe at the moment that you can discuss?
Yeah, we have a big one running with a big retail big retailer in Germany. I can't name them. It's obviously, well, maybe not obviously, but it is classified. We can't talk about it. But what I can do is kind of talk you through what they're doing. So they have their fulfillment centers, and they have their kind of trolleys driving around with pallets on them, and there's people doing the palletization. So the problem that they have is that they actually know what needs to be on the pallet, and so the trolley is driving around to the workers, and the workers know what they need to put on the pallet. But what actually happens a lot is that they don't palletize effectively. So after maybe 80% of the order is packed, they're unable to put the rest on it. So they have to take everything off again, put everything back on the pallet in the right way before they can ship it. And that's obviously not very efficient. They're losing a lot of money out of because of it. So we are working now with them on a solution that actually would indicate where to put the package on the pallet. So kind of by flashing a light, saying on the location, saying, well, put the package over there. So yep, that's a big project. They have a couple dozens of fulfillment centers, so really big.
And just finally, to wrap up the Q&A session, Niels, is in general, how much work is it to install, and how long is it before I start seeing value from it?
Yeah, so the installation, like I said, it can probably start at maybe like 2 weeks is probably the minimum that I've seen, up to maybe typically something about 3 months to get something up and running and show proven ROI. And then it's a matter of moving that to kind of what we call a production rollout, scaling it up to run everywhere, and repeat that same thing in the whole warehouse, or in the collection of warehouses. So that's something that that can take a couple of months. It really depends. Seeing the ROI, it can be like I said, the use case that I showed, we're talking about like 7 months for seeing the break-even point. But yeah, it's something that we really always do as part of a digital experiment. We make sure that we do this business value assessment, and so that you make sure that it actually gives you the return on investment. Because otherwise it would just be kind of like a technology fest, and we really want to solve a problem that provides value to customers.
Absolutely. Well, Niels, thank you so much for that. I'm afraid the webinar's now coming to an end, so I hope everybody out there watching it has enjoyed it, and I'd like to thank everybody for watching it, participating, and especially for voting in our polls earlier. I would also like to thank our sponsor today, AD-Link, and I would also like to thank our speaker, Niels Courtsey, Product Director, Edge Solutions at AD-Link, for his time and expertise and working through his faulty webcam as well. So thank you, Niels, for your time this morning. That's been great. As I said earlier, don't forget there's a recording of this webinar available on logisticsmanager.com, so you can catch up, share with your colleagues later this afternoon. We've also got a series of webinars coming up, counting down the Logistics Manager top 50 service providers, featuring our sponsors West Coast, Clipper Logistics, Logicor, and Kinaxia Logistics, coming in December. So look out for more details on those. They're going to be great. And that's it. So thank you again for attending this webinar. Thank you to our speaker and our sponsor, AD-Link, and we look forward to seeing you soon. Thank you. Goodbye.